All right, 8.4 is talking all about more quadrilaterals, but more specifically rhombuses, rectangles, and squares. So what a rhombus is a parallelogram with 4 congruent sides. So typically, this is what we envision when we envision a rhombus, but this is not what a rhombus has to look like. We envision what looks like a parallelogram, so it's been pushed in on one side, but all sides are congruent on it, okay? But a rhombus, by definition, could look like a square, because by definition, a rhombus just says is all 4 sides are congruent. A square is a subcategory of a rhombus. It's a more specific type of rhombus. All 4 sides are congruent. Or we can just push it on one of the corner and it can be slanted over. Okay. A rectangle is a parallelogram with 4 right angles. So this is typically what comes to mind when we talk about a rectangle. 4 right angles. Something that looks like that. By definition is still a parallelogram, so opposite sides are congruent and parallel. But again, just like we said on a rhombus, a square is technically, by definition, also a subcategory of a rectangle. It's a more specific type of rectangle. So then we have a square. So a square is a parallelogram, but it's also a combination of a rhombus and a rectangle, because it has to have all 4 sides congruent, like on a rhombus, but it also has to have all right angles, like on a rectangle. A rhombus corollary is a quadrilateral is a rhombus if and only if it has 4 congruent sides. So that if and only if, remember that's our best definition. We learned that back in all the way back in Unit 2 when we were talking about conditional statements and biconditional statements. So that is a biconditional statement where we take out the if and then part and put in the if and only in if part in the middle. Rectangle corollary, a quadrilateral is a rectangle if and only if it has 4 right angles. So it has to have the 4 right angles to be a rectangle. So essentially they're taking these definitions and writing them in what we call the best definition in a biconditional statement. And then square corollary, a quadrilateral is a square if and only if it is a rhombus and a rectangle, which we talked about that above. Theorem 811, again, I don't need for you to memorize the number. I do need for you to understand what it is saying and the general idea behind it. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So if I were to draw a rhombus here, remember that is a quadrilateral with all 4 sides congruent. And then if I draw its diagonals, what they're saying here is that these diagonals will meet at an intersection at a 90-degree angle. By definition of a parallelogram, remember that this is congruent to this and this is congruent to this. So a square is a type of rectangle, or a type of rhombus, right? So that means on a square, if I were to draw a square, its diagonals would intersect at that 90-degree angle also. Okay. Next, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So I'm going to draw my rhombus. So what it is saying, it's bisecting these little angles down here. So what happens is this one is the same as this guy is the same as this, and then these 4 are congruent to one another also. And then last one is a parallelogram is a rectangle if and only if its diagonals are congruent. So a rectangle, if I draw its diagonals in, so these do not necessarily meet at a 90-degree angle, but all 4 pieces are congruent. That then means that on a square, if I were to draw a square and draw its rectangle, or its diagonals, they meet at a 90-degree angle, but they're also all congruent. Okay, next page. It says, for any rhombus ABCD, decide whether the statement is always or sometimes true. Draw a diagram to explain your reasoning. So it's a rhombus A to B to C to D. So I'm going to draw a rhombus. When I label this, I have to go around in a circle. It doesn't matter where I start. It could be drawn to scale, it may not be, but they're saying that the angle A to B to C, so this angle, is congruent to C to D to A, and that angle. And so that is always true. Because that is, because that is the definition of a parallelogram. The opposite angles are congruent. And a parallelogram, a rhombus is a type of parallelogram. All right, next one, draw a rhombus again. A, B, C, D. They're saying C to A is congruent in length to D to B. So they're saying the diagonals are congruent here. Well, if we think about this, and if we go back, a rhombus, and even if I look at it, they don't even look like they are congruent, because a rhombus doesn't have to have congruent diagonals. The specific type of rhombus that has to have congruent triangles is a square. So if we had a square that was a rhombus, then it would be true. But if we had a rhombus that looked like this, it would not be true. So that would be a sometimes true. So sometimes, if the rhombus was more specific and was a square, because remember, a square is a combination of a rhombus and a rectangle. Okay, so all squares are rhombuses, but not all rhombuses are squares. For any rectangle, so now we're doing rectangle, so let's do rectangle. I'm going to draw a rectangle. I have to go around in a circle. F, G, H, J. Decide whether it's always or sometimes true. They're saying F is congruent to H. Well, this is always, because one of the definitions or theorems of a rectangle is that we have 90-degree angles everywhere, so they are always true. If I'm thinking about this guy using this picture, it's saying that G to H is congruent to H to J. Well, in this picture, they don't look like that is true, right? But if I were to draw a square, remember that's our more specific rectangle, then that would be true. So this would be sometimes. So if the rectangle was more specific and was a square, then yes, it would be true. But if it's not necessarily a square, it doesn't have to be all congruent. Name each quadrilateral, parallelogram, rectangle, rhombus, and square for which the statement is true. So it's equilateral. That means all sides are equal. So that would be a rhombus and a square. Go ahead and pause me and try 6, 7, and 8, and then unpause me when you're done. This next one, so this has to be true at all times for this figure for us to write it down. The diagonals are congruent. So that would be a rectangle and a square. It can contain obtuse angles. That would be a parallelogram, can contain obtuse. Remember, obtuse are over 90 degrees. A rhombus can contain obtuse angles, but a square and a rectangle both contain 90-degree angles, which are not obtuse. It contains no acute angles. Well, rhombus and a parallelogram, if they contain obtuse angles, they have to contain acute angles. So a square and a rectangle do not contain any acute angles because they only contain 90-degree angles. Classify the special quadrilateral, explain your reasoning, and then find the values of x and y. So this is 90 degrees, and then those are all congruent. So this would be a square, because it is a combination of a rectangle with a rhombus. So that means that all sides are equal. So I could say 5x minus 4 equals 3x. I can solve for that. I'm going to move the 3x this way by subtracting it, add the 4 at the same time. So I get 2x equals 4. So x equals 2. And then to find y, same thing. This is congruent to this, so I'm going to do 5y plus 1 is equal to 2y plus 4. Subtract 2y, so I get 3y. Subtract 1 and I get 3, so y equals 1. This one, so we have all congruent sides, but we don't have all congruent angles. This would be a rhombus, because I have the congruent sides. That also means that this would be 127. That means that these two add up to 180. So I could do 2x minus 1 plus 127 equals 180. So this is actually 126 if I put that together, and to move it to the other side, it's subtract. So 180 minus 126 is 54. So I get 2x equals 54. Divide by 2 and x equals 27. Y, that's finding those side lengths. So side lengths are congruent. So I just set them equal. 6y minus 5 equals 3y plus 7. So subtract the 3y and I get 3y. Add the 5 and I get 12. Divide by 3 and I get y equals 4. Okay. This one does have 3 pages. So go to the last back page. Find the length or angle measure. So this is a square. They're saying that these two are sides of a square. Well, sides of a square are always equal. So to find x, I just do 1 minus 10x equals 14 plus 3x because all sides are congruent. I'm going to add 10x, but I'm going to minus 13. So if I add 10x, I get 13x minus the 14, and I get negative 13. So x equals negative 1. xy is a side on this, but it's going to be congruent to the other two sides because all sides are congruent. So I'm going to plug in the negative 1 to either one because, again, it's a square, so all sides are congruent. So I'm going to do 3 times negative 1, which is negative 3. So 14 minus 3 is 11. So xy has to be 11 also. Go ahead and pause me and try 12 and 13 on your own. Okay, so we're going to look at these two real quick. So this is a rhombus. So I drew a rhombus and I labeled the sides. They're telling me that x is 240 minus 24x, and they're telling me that z is 6x plus 90. Well, if I look, those are across from one another, so those will both be the same angle measures. So I set them equal to each other, and I went through and I solved for x. X is 5. So then what I did was I plugged the 5 back into this equation. It doesn't matter which one it goes into, it will give you the same answer. 6 times 5 is 30, plus 90 is 120. So I get this angle is 120 and this angle is 120. But they wanted us to find angle y. And so we have to remember that these two are supplementary. They add up to 180. So I do 180 minus that 120 that I solved, and I get 60 degrees. This guy is not drawn to scale because when I drew it, I didn't know which angle would be the obtuse, and I didn't know which one would be the acute, so I just labeled it as is. This one is a rectangle, so I drew rectangle WXYZ. But then they're talking about triangle XYZ. Well, triangle XYZ, I'd have to have a line in here to make that triangle. So I put in its diagonal. They tell me x to z is 13 minus x, and then they tell me that this side plus this side is 5x minus 1, and they tell me that the perimeter of that is 24. So I take that 13 minus x, the diagonal, plus the 5x minus 1, which is this guy right here, and I set that equal to 24. And then I go through and I do all the math, and I get x is equal to 3. So they actually want w to y, but w to y's diagonal length is going to be the same as the diagonal length for x to z. So I just plug in the 3 for x to z, and I get 13 minus 3, which is 10 for my answer. Okay, the diagonals of the rhombus PQRS intersect at T. Given that the measure of R to P to S they labeled is 30, and R to T is 6, find each of the following. So pause me and find each of those. And then go ahead and do through 20, actually do the rest 14 through 25 and read the directions. Okay, let's go through and talk about these. So Q to P to R would be this guy. That is 30 degrees because this diagonal bisects it. That's a property of a rhombus. Q to T to P, this angle, that's a 90-degree angle because the property of the rhombus says the diagonals meet at a 90-degree angle. R to P would be the whole way, so if half the way is 6, the other half would be 6, so together that makes 12. And then Q to T, guys, I had to take this triangle out, label that this is a 30-degree angle. We know that this is 6 right here, and I'm actually finding my short side. But this is a 30, 60, 90 triangle, so your information from Unit 7 you're needing in this unit for SOHCAHTOA, and also for 30, 60, 90, and 45, 45, 90 triangles. So if I labeled that as a 30 and this is 60, we're going from medium side to short side. So that's where I divide by the square root of 3. And then I need to rationalize the denominator. So I get 6 square roots of 3 over 3. 6 divided by 3 is 2. So that's 2 square roots of 3. 2 square roots of 3, 2 square roots of 3 is 3.46 if you got the decimal. The next one, W to X to Z, that's 40 degrees because this is 90 minus that 50. W to P to X, this angle up here, this is 40, and on a rectangle, this one would be 40. They're going to be congruent, whatever is down here. If this is 50, that means this is 50. This makes 90, so that makes that 40. That makes this 40 and this 50, so they're all between 1 and 2, all between 2 angle measures. So I would do 180 for this triangle, minus the 40 and 40, which would give me 100. P to Y is 6 because they told me the directions X to Z is 12, so half the distance, because all those are congruent, is 6. I'm going to do the rest on the next video.